In this video, we'll find if the given number is prime number or composite number. Prime number is nothing but a number which has only two factors. Two factors in the sense that number will be divisible only by those two numbers, those two factors. So we know 1 is a factor of all the numbers, and that number itself, it can be divided by that number itself. Every number is divisible by 1, and in prime numbers, that particular number is divisible by itself. That is called a prime number. It has only two factors, that is 1 and that number itself. Composite number, it will have more than two factors, that is 1, that number, and other factors. That is composite number. So we know like 1 is neither prime nor composite, it belongs to both. So we know the prime numbers are 2, 3, 5, 7, 11, 13, and it goes on like that. All these numbers has only two factors, 1 and that number itself. There are composite numbers like 4, 6, etc. Okay, so now we are going to find if that given number, the number entered by the user, is prime number or composite number. So let's take it as n. Now as of now, let's take it the number as 5. Okay, now we are going to enter into a loop, that is for I is equal to 1, I less than or equal to n, and I plus plus. Why are we starting with 1 is because you cannot divide a number by 0. So that's why we are starting it with 1 and ending with that number itself. So we know 1 is a factor and n is another factor. We are going to find whether there exist any other factors in between these numbers, that is 1 and n. What we are going to find is again the modulus. For even and odd program, we found the modulus to find whether it is even or odd number using the remainder. If remainder existed, it was odd, and if there was no remainder, that is remainder was 0, we consider it as even number. So here what we are going to do is n mod I we are going to find. If we get the remainder as 0, then we are going to increment an integer variable. We will be assigning it as, let's take c is equal to 0. We are going to initialize it as 0, finding whether this n is divisible by any of these numbers. So it is divisible by 1. So c will increment. Now it will be 1. When I increments, I will be equal to 2. That times n mod 2, that is 5 mod 2, it is not divisible. So c won't be incrementing. I is equal to 3 means 3 is not divisible. It is not divisible by 3. So I won't increment. I is equal to 4. 5 is not divisible by 4. So c won't increment. And next I is equal to 5. The last value in the loop, it comes to it. I is equal to 5 and that comes, so c will increment and it will be 2. Now if you check for any other values, maybe n is equal to 11. Let's see, when I is equal to 1, 11 is divisible by 1. So c will be equal to 1. I is equal to 2 means 11 is not divisible by 2, not divisible by 3, not divisible by 4 also. 5 it is not divisible. When you check for 9 and 10, for both it is not divisible. For 11 if you check, it is divisible. So c will increment. That means c will be equal to 2. Now from this what we can conclude is that for every prime number, the value of c is 2, because it has only two factors. It is divisible from 1 to that particular number. When we check the divisibility, it is divisible only by two numbers, that is 1 and that number itself. So we can keep the condition like this: if c is equal to 2, then that is a prime number, else it is a composite number. So this is one logic. Another method what we can do is, we are finding the composite number. Here we are finding the prime number. That means we are checking if that particular number has two factors only. That means we are finding the prime number. Next we are going to find the composite number. For that, let's keep n value as, again we have to run the for loop. For I is equal to 2. For composite number, we'll be for this method, we'll be starting with I is equal to 2. I is less than or equal to n by 2. I plus plus. Here again we are checking the same condition. If n mod I is equal to 0, we are checking if n is divisible by I or not. So why are we not including 1 is because we know that n is divisible by 1. So as we are finding a composite number here, we know it is divisible by 1, and we know that all prime numbers are divisible by 1 and n. So 1, 2, 3, 4. In the last method, we checked whether C is equal to 2. That means it should be divisible by 1 and 4 and the remaining condition should be false. But here what we are doing is, we are starting with the second number, I is equal to 2, I less than or equal to n by 2. N by 2 means 4 by 2 is 2. So we are checking only this, because we know composite numbers are divisible by 1 and that number itself. So we are not going to check that. We are checking whether it has any extra factors other than 1 and that number. So to save the time, we needn't traverse till the end. We can find it till the half of that array itself. Array in the sense that list from 2 to the final number. We can take the half of that list and we can check, because we know that first number exists in 1 and last number exists in the n value. So our aim is to find if there exists any other number other than these two. So we can obviously find it in the first half itself. We needn't traverse till the end, because if anything has a factor other than 1 and that number, it would obviously exist between the half of that consecutive integers. So if we find that, so this condition is nothing but when we give I is equal to 2 and I is less than or equal to n by 2, we are not finding whether it is a prime number. We are finding whether it is a composite number, because we are finding the extra factor. We are not including 1 and that particular number. We are finding extra factors. Okay, so when we find that there exists an extra factor other than 1 and that particular number, we'll be breaking the loop. So here we need to assign something, maybe a flag value. So flag is equal to true. We can take flag as a boolean value. Flag is equal to true, and we are breaking the for loop, because we found it. It is a composite number, it has an extra factor. Now when we break the loop, we'll be checking if flag means flag is a boolean number. Boolean in the sense, if you're giving just flag, it means it is true. Okay, so when flag is true, we'll be printing as composite number, else we'll be printing it as prime number. Okay, so these two are the methods which could be used for finding if the number is prime or composite. We can use the second method as it is more easy. So let's try to implement this method in C and Java. So n is the variable in which we are going to store that value, and printf scanf statements are given. Now we need the for loop. For int I is equal to, we are starting with 2, I less than or equal to n by 2. We are getting only till the half of the values. Then I plus plus. Now we'll be checking if n mod I equal to 0. N mod I equal to 0 means there exists an extra factor other than 1 and that particular number. That time we'll be assigning a flag variable. Flag is equal to true. Before that, we need to initialize that flag variable. Flag is equal to false. So by default it will be false. When it enters the for loop, and if this condition comes true, this condition becomes true, then it would be changed as true and we'll be breaking the loop. After the for loop, we have to check if flag, that means flag is true, then we'll be printing it's a composite number, else we have to print it's a prime number. And one more thing we have to check is, in C program we can give it as only bool. Data type is bool. In Java we'll be using as boolean. Okay, so now let's run this code. So we are going to enter the number 100. 100 is a composite number. It has more than 2 factors. It is divisible by 2, it is divisible by 10, like that the factors it goes on. So it is a composite number. When you give 2, it is a prime number. When you give 1 or 3, it is divisible only by 1 and that number itself. So it is a prime number. One more thing what we can do here is, if the entered number is 1, it is neither prime nor composite. So we need to print that. So before checking all these things, we'll finish it off. If n is equal to 1, we'll be printing it as neither prime nor composite number. And after that, we needn't check all these things. We are going to return this program. Otherwise, we'll be returning it in the end. So now if we check with 3. 3 is a prime number. Now if we check with 1, 1 is neither prime nor composite number. So it ends there. That whole program ends there. We needn't check the remaining statements. Now let's do the same program in Java. Here also we'll check that condition. If n is equal to 1, we'll be printing system.out.println n neither prime nor composite, and we'll be returning the program. Else, if this is not true, then we need to go for the for loop. For int I is equal to 2, I less than or equal to n by 2, I plus plus. The logic is same for both C and Java, just the syntax differs. So if this condition is true, we'll be in this for loop we have to check the condition as if n mod I is equal to 0, then flag is equal to true, and we'll break the loop. Flag, we need to initialize that flag variable. So here we'll be giving it as boolean flag is equal to false as the default value, and then if it is true, then we'll be assigning it as true. And after the for loop, we need to check if it is flag, that means the flag is true, then we'll be printing it is a composite number, else we have to print it is a prime number. Okay, so now let's check again. The number could be 98. 98 is a composite number. It has more than 2 factors. When you give 83, 83 is a prime number. So this is the logic for finding if that given number is prime or composite. You can use the other method also, by which we'll be implementing it using an incremental variable c, and we'll be incrementing it till 2, and if that value is 2, then it is a prime number, otherwise it is going to be a composite.